Okay, this is exercise 313. I'm just going to go through one of the questions from question 12 here, and then you can try the rest on your own after that. So just going to look at question 12a. We've got to write each polynomial as a product of its factors, and then we've got to sketch the graph and describe its shape. Okay, so let's have a look at 12a. So first part is part 1. You've got to write it as a product of its factors. Okay, well, we'll notice that all of these have an x in it. So I'm going to write p of x with a common factor of x. And then there's x squared minus 2x minus 8. Okay, now you notice that this is a quadratic, so we'll try and factorize that. Keep the x there, two lots of brackets. X times x is x squared, and I'm going to put a 4 here and a 2 there, negative there, positive there. Okay, so that's the quadratic factorized. So now the cubic that we started off with has been written as a product of its factors. Okay, that is done. Part 2 of the question says sketch the graph. Okay, so that's what we'll do now. Now, what do you need to sketch the graph? We need the intercepts, don't we? So for part 2, let's find the x-intercepts. Okay, how do we do that? We put the y value equal to 0. Okay, so solve that equal to 0. So clearly x equals 0, x equals negative 2, x equals 4. Okay, now what about the y-intercept? Well, for the y-intercepts, you put x equals 0. I'm just going to use that expression here, what I started with. If I put in x equals 0, what do I get? Okay, so sub x equals 0. Therefore, y is equal to 0, right? Because all of these terms will become 0. So it goes through the origin. That's good to know. What else can I do to sketch it? Well, I know that my leading term, so if I look over here, leading term, what is that? Leading term is x cubed. Okay, that's x cubed. And think of this as 1x cubed. Okay, now I've got a positive coefficient for the leading term. Also, I've got a odd degree. Now, that means I'm starting in this quadrant and finishing in this quadrant. Okay, so now we're ready to sketch. Okay, so I will, now I'm doing this on a graphics tablet, so this is going to be quite rough. There's my y-axis. Here's my x-axis. Actually, I can do better than that. What I can do is I can use the line tool. Okay, so there's my vertical axis. Here's my horizontal axis. That'll do. Yep. Now I just got to put some numbers on there. And can I add a grid? I can. So look up here. I don't think so. No grid at the moment. No. All right, that's okay. So we'll just do by freehand then. So call that 1, and 2, 3 and 4, and I'll call that negative 2. All right, now I'm going to sketch my cubic now. Now I know that what quadrant I'm starting in, here, and finishing in here somewhere. All right. Now, put in your intercepts. So there's an intercept there. There's one at the origin, 0, 0. And negative, and then I've got 4 as well over here. Okay. All right, so I'm ready to sketch. So I'm going to go through here, and through here, and then through here. Okay. There is my first cubic. That's y, that's x. Okay, so I've done it does say describe its shape. So with shape, we're talking about concavity, aren't we? So you can see maybe that section there of your cubic roughly is concave down and the other section is concave up. So I would say it curve is concave down. I guess you could say curve changes from concave down to concave up. Concave down to concave up. Starting in the third quadrant. Third quadrant. And finishing in the first quadrant. Oops. Okay, that's what you could say about the shape. You could also say there is a local maximum. Now, we don't know exactly where the local maximum is. We don't know exactly where the point of inflection is, so it's hard to say exactly where these points are. But if you're talking about the shape, I'd be saying there is, we're just talking about the concavity of the curve. Now, let's look at the question 14. I've got to show that this is true. We'll just expand the brackets for part A. So for part A, you're just going to expand the bracket. So I'll do the last two brackets first. So what's that? X squared minus 4, difference of two squares. Yep. And then expanding from there, I'm going to get x cubed minus 4x minus 3x squared plus 12. And obviously I can put that in this order. Done. Sketch the graph. We're just going to do the same thing as before. Now they've already given the polynomial to you as this. They've already given you the factors, haven't they? So you've got x minus 3 x plus 2, x minus 2. Okay, so you're going to first look at finding the x-intercepts. So you've got, so for x-intercepts, you're going to solve polynomial equal to 0. So you're going to get x equals 3, x equals -2, and x equals 2. For the y-intercept, you're going to sub in x equals 0. And when you do that, when you sub x equals 0 into this polynomial, because after all that is p of x as well, isn't it? You're just going to get 12. So I'm going to put therefore y is 12, so that's your y-intercept. Then we're going to look at sketching that. Okay, so let's draw the axes in, put some numbers. So what have we got? We've got to go up to 3. 1, 2, 3. And there's 2, and there's 1. And we've got to go up to -2, so that's -2 there. Now, look at the leading term. Here it is. Leading term is x cubed again, isn't it? Okay. So if you look at the leading term, which is x cubed, treat it as 1x cubed. So it's got a coefficient of a positive coefficient for the leading term. So you know that also being odd degree, just like before, you'll start in the third quadrant, finish in the first. So let's sketch the cubic now. And I know somewhere up here is my y-intercept, y equals 12. So I'm starting down in the third quadrant, so somewhere down here. Okay, I'm going to mark in my intercepts, which is negative, let me just check those, -2, 2, and 3, yep. So -2, just there, 2, and 3. Okay, so starting in the third quadrant, coming up, somewhere I've got to come down. Whoops, that wasn't so good. Try that again. Okay, so coming up, coming down, and up again. There we go. Now, do I have to worry about a scale on the y-axis? No, because I've only got to show one number, so I'm just going to say, well, there you go. There's 12. That's the y-axis, that's the x-axis, and that's it.